TTL Computer 2. Today we will be testing our program counter printed circuit board, and we're going to be utilizing our testing jig that we built a little while back. And you can see that we have this all wired up in our testing jig. I did post to the community pages the testing jig patch wire diagram, so that's there for you to take a look at if you care to see the details. But we basically have our output signals coming to our display unit. We have our data bus connected to our first row of switches here. We have our control signals wired into this switch here, and that's going to be the counter in low, counter in high, counter enabled, and our clear signal control signals are hooked up here. And then we have our T clock wired patched into our switch number 1, and then we have our switch number 2 is wired into both the counter out high and the counter out low signals. So in its default state now, it's showing the counter out low. When we press that, it will show counter out high on our display unit. Okay, so I'm not quite sure how we're going to do this today, but we'll take a stab at this. So this is my test plan that I also posted to the community pages. And I'm going to just give you a spoiler that I already did go through and complete the test plan, and our board passes. So what I'm going to do is really just my intent today is just to give you a flavor of what how the testing proceeded for the board. Okay. So I'm going to start going through the test plan. So just the first part of our test plan is is set up. So our data bus is supposed to be low, and it's high right now. So let's bring these all low. All right, our data bus signals are low. All right, so that's passed. All of our control signals are high. That's passed. That's our first clear test. So we want to bring the clear signal low. And I've done that. Just check that off on our test plan so we keep track of where we are. Clear signal back to high. Okay. And we see that our counter out low is what we're showing here, is 0. And I'm going to switch to counter out high, and both are 0, right? So we just did our clear test, and that passed. So now I'm going to do a test for counting. And I'm going to press the clock. So that's our first clock, and we see we got our signal and 2. So we counted up to 2. All right, so that's just a counting test. And so that's our counter out low, and I'm going to press counter out high, should be 0. And it is after that counting test. So we passed our first 2 tests, right? We tested the clear, and we did a simple counting test. Now we're going to do a negative counting test, or we want to disable the counter enable, bring counter enable low, which I just did. And we're going to just count again. And as expected, right? Counter is disabled, so with the clock, it's not advancing. So that's a good test there. Counter enable back to high. And we take a look at the counter out high now, and that's still 0, right? So that's our second pass. So that's a counter enabled test. All right, so now we're going to go and we're going to be testing the ripple carry out test. So first thing we're going to do is we're going to clear everything out. We want to bring our clear signal low, back to high. Back to high. And so counter out low is 0, counter out high, also 0. That's what we would expect. after we did the clear. All right, so now we're going to do our first ripple test. And we're simply going to count, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now here's our going to 16 is our ripple carry out, our first ripple carry out test. And there we went to 16. So that was a good test of our first ripple carry out. Counter out high is still 0. Okay. Now we're going to bring the counter enabled low. All right, our data bus now, we want to load in FF. Okay, so our data bus has FF. Now we're going to do a counter in test. So we want to bring counter in low to enable that. Okay, we're going to do advance the T clock. Okay, so now we loaded in FF from the data bus. So that's a good test. Counter enable low back to high. Counter enabled back to high. And now we are going to do, this is going to be our ripple carry 2 test. So we're back to FF on counter out low, counter out high 0, and 1 clock, T clock, advanced. Okay, so that goes to 0, right? Because that overflowed back to 0. And counter out high should be 1. And it is. All right. So that's our second ripple carry out test. Okay, so we want to say counter enabled low. We've done that. Our data bus is at FF. It already is. We want to counter enable counter in low. We want to bring that low because we're going to load that. Okay, and we're going to clock that in from the clocked in FF from the data into the counter out low. Want to bring counter out low back high. And our data bus, we want to just have 0F. All right, we have 0F on our data bus. Yes, that's correct. Now we want to bring counter in high low because we want to load that. Counter in high low. Clock that in. So counter in high low is whoop. Oh, that was high, right? So counter in high, we already clocked that in. We did this, okay. Counter in high, we bring that back to high. All right, so now we do counter out high, and there's the 0F. All right, so the counter out low has FF, counter out high has 0F. And now we want to go back to count. We want to enable the counter again. Okay, so now we're all set to do our ripple carry test again. We want to clock, so we're at the counter is at 0F FF, and we just did our counter. We did our clock press, so we have 0, and then we should have 1 0, and we do. All right, so that was our ripple carry 3 test. All right, that was all good. And what the heck, we'll finish up and do the whole complete test plan. All right, so we have counter enable. We want to bring that low. Data bus, we want to have FF. So our data bus has FF on it. We want to bring counter in low, low to load that. That's low. All right, so we clock that into the low. Low, we want to bring this back high. D bus has FF, their data bus. Now we want to bring counter in high, low to enable that. And we did. We want to clock that in. All right, that's still showing counter out low. We just clocked in counter out high, counter in high. Let's bring this back high. We did. Now we're going to take a look at counter out high. All right, so both counter in high and low, both is at FF. So our program counter is ready to roll over. All right, so we want to bring our counter enable back high, which we did, and now we're going to do our T-clock. All right, so that's counter out low, rolled over to 0, and counter out high, rolled over to 0 as well. So that was our final rollover test. And that completes a full run through of our test plan for our program counter card. And that was a successful test. So what's our status here on our build? So we've built our clock card, and that's been built and validated and tested as okay. We built our testing jig, which we utilized obviously for the testing. And we built our program counter card, and we have gone through a successful testing of that with the jig. So our next phase of our build will be our memory address register card, and that's going to be, again, it's substantially the same as the program counter card. So it's really just a 16-bit output instead of an 8-bit output. So we should be doing proceeding at a pretty good clip, and we have a good success rate on our board testing. So I hope that was I hope you could follow through on that testing. Pretty detailed test for the board, and pretty good use of our testing jig, and you get to see how the patching of the board works. Okay, so that's it. Until next time, thanks for watching.